All right, so chapter 2. The first lesson, we are going to be dealing with functions, domain, range, interval notation. Today, we're going to focus on what's a function and what's the domain and range of a function. On Tuesday, we are then going to address what's interval notation and how do we write domain and range in interval notation. So today, we're going to use inequalities to do this. And then on Tuesday, we're going to look at how to do it with interval notation. All right, so relations. It's anything that pairs an element of one set to an element of another set. Ordered pairs, equations, points on a graph. Relations just take one variable, relate it to another variable. In this case, we say it takes an element of the domain and it compares it, relates it to an element of the range. Everything that we can deal with when we start graphing is a relation. A function is a special type of relation. It's a relation where each value of the domain only goes to one value of the range, which is a very mathematical definition. Domain is the x variables. If we can go to basic terminology. Range are the y variables. So if I go back to the definition of a function, each element of, just take that down. Each element of the domain goes to only one value of the range, which means each x has only how many y's attached to it? 1. There are, what we say, no repeating x's. Because if I repeat an x, if I say 2 relates to 4, and I say 2 relates to 7, that means I have two different y's with the same x. So we have all functions are relations. A function is a special type of relation. But not all relations are functions. And here's what we can look at if something's a function. We can apply the definition. Each x should have only one y attached to it, and that's where we say no repeating x's. So you have a list of what is a function. 1, 2, 3, 4, 5, 6, those ordered pairs. You notice the x's are not repeating. Each x is unique. But if I go to not a function, 1, 2, 1, 4, 1, 6, I have repeating x's, which means that x has more than one y attached to it. That's not a function. Equation-wise, if I plug in an x here, pick a number, any number. 2. Plug in 2, I get 6. Now let's plug in 2 again. What do we get? 6. Same number, correct? You don't get something new, do you? If I plug in 3, I get 7, don't I? If I plug in 3 again, what number do I get? 7. So each x has a unique y, correct? I can plug in 5 50 times. I'm still going to end up with 54, aren't I? Every single time. So each x has one number that is attached to it for the y. But if you look at the not a function, if I plug in 3 here, what's 3 plus 1? 4. What's the square root of 4? 2. Do you guys remember what this symbol is at all from Algebra 1 at all? Plus or minus. I have a different name for it. I get tired. We used it a lot in Algebra 2 and pre-calculus, so I got tired of saying plus or minus, plus or minus, plus or minus. So I call it the plinus. Just combine the two words together. Now what happens is you'll go to pre-calculus, you'll have another teacher, you'll call it plinus, and they'll shake your head at you. Who cares? So I call it plinus. What's the square root of 4? So really this is plus or minus 2. I plugged in how many x's? 1. I plugged in 3, didn't I? We plugged in 3. How many y's did we get? 2. So that's not a function. 1x gave us 2 different y's. You cannot have that. If 1x gives us 1y, that's a function. Now this, you learned in Algebra 1, is called the vertical line test. If you want to determine something's a function, it can only intersect once. It can only intersect once. If it does not intersect once, if it intersects 2 times or 3 times, it's not a function. So if I were to imagine a vertical line being dragged across the graph, how many times is it going to intersect at the most as it's being dragged? Once. That means one x has one y. There's only one intersection point. Even here, if I drag across, you see it intersects once there, intersects once here, intersects once here. That's a function because there's only one point. But if I go over to this one, how many times does it intersect? 2. Now, what does that mean? This x value, let's call it -7, has how many y's attached to it? 2. The vertical line test is a visual way of applying this definition. Each x here has a different y attached to it, doesn't it? A vertical line test shows that. Same thing over here. If I were to draw a vertical line here, you see it intersects twice. It does not work. All right, let's try number 1. When dealing with domain and range, if you're given coordinates, so if I'm given coordinates, you want to list them least to greatest. Do not list repeats. So in the first one, domain are your x values. Does anybody know an easy way to remember domain is x and range is y? This got me through high school math. Nobody knows an easy way, domain's x, range is y? Yeah, got me through high school math. Alphabetical. D comes before R. X comes before Y. Got me to understand domain and range. Domain is the X, range is the Y. Alphabetical. Silly ways to remember some of the mathematical terms. Now I understand, but when I was studying, I just had to figure out something to help me. So what are your X values? 2, 4, and 6. This is called a brace. If you cannot draw a brace, do a parentheses and then kind of trace out a triangle. And you kind of see a brace. Then you start to practice it more and more and you get a brace down. Brace tells you sets of numbers. That's what a brace tells you. What's your range? And don't always copy down in the order they appear. It just so happens the order they appear is least to greatest, doesn't it? What's your domain for number 2? 4 and 16. I'm only going to list 4 once. We do not list the repeats. It goes 4, -2, 16, 4, 4, 4, 16, -2. Though the 4 and 16 repeat, I'm just going to list it down. What's your range? -2, 4. The x values and the y values. Now, we didn't answer these questions. Is the first one a function? Yes or no? Why? No repeating x's. Is the second one a function? No. Why? X equals 4 and x equals 16 repeat. This is always a fun one. It's easy when I give you a set, but what if I give you an equation? Y equals 3x minus 4. What's the domain? Domain are what values? X values, right? Everybody watch this. All right, pick an X value. Any. What? 4. Plug in 4, you get 8, don't you? Good. So this is not your domain. X value. 12. You plug in 12, you get 32. 1. You get -1. 7. What do you get there? 17? What do you get? Pick. 5. And in that case, you get 11. Pick. 3. You get 5. Where are you guys getting your x's from? You're just picking randomly, right? Could you have said 10 and gotten 26? Could I have said 100 and gotten 296, right? Could I have said negative 500? And in that case, get negative 1,504. Yes? When you are plugging in an x, what x's can you choose from? What numbers can you choose from if you're plugging in an x? All numbers. That was the point. You could have picked any number you wanted and plugged it in, correct? This is a linear function, slope-intercept form. The domain is all real numbers because you could pick any x you want and plug it in. Range is the same thing. Every time we spit out a y value, when you plugged in an x, they were different, weren't they? I was going down forever, I was going up forever, I could have plugged in negative 1,000, negative 2,000, and so on. I could have plugged in 1 million. So domain and range, this is always true for you guys. Domain and range for a linear function is going to be all real numbers. Always. That's from lists and equations. But how about from a graph? If I want to do domain and range from a graph, domain is which values? X. So if you have an x-axis, your domain describes the x. So let's do that. Take your pencil. Morning. Happy Friday. Take your pencil. Seriously, take your pencil. Turn it vertical. This is what we're going to do for interval notation too, so we're practicing for Tuesday. Start. It goes least to greatest, correct? So on the x-axis, where's your least? To the left. Take your pencil vertically, go to the left. As you drag it across, when's the first time it hits the graph? What x value? Negative 4. So if I do negative 4, is it still touching the graph? Still dragging, right? Still dragging, still dragging, still dragging, still dragging, still dragging, still touching until what number? 2. The question is, how do I say that this graph exists from negative 4 to 2 on the x-axis? It begins at negative 4, it stops at 2. Which variable are we dealing with? We said x-axis, right? The x is between these two numbers, aren't they? Your graph is between those two numbers. It's less than or equal to 2, isn't it? It's greater than or equal to 4. What type of inequality is that? An and. It's an and compound inequality. From negative 4 to 2, your x in between. That's domain. Vertical pencil, left to right. Where does it start? Where does it end? Do that for the range. If I do that for the range, what am I going to do with my pencil? Turn horizontal. I'm going to go where? Down here, right? Least to greatest. As I go least to greatest, what's the first part my pencil hits the graph? Negative 2. What axis are we dealing with? The y, the range. It's still going up, still going up, still going up, still touching until what y value? 1. So it's below 1, but it's above negative 2. Your y is between those. The graph is between these two numbers, which I can see it is, between negative 2 and 1 on the y-axis. That's domain and range for a graph. You use your pencil, and majority of the time, it's going to be a compound inequality in some way. So, is this a function, yes or no?
No.
Why do you say no?
Oh, my bad.
Tibbs, when I do a vertical line, does it ever intersect more than once? No. So yes, it's a function. Number 5, domain, vertical pencil. By the way, you know what's really helpful about doing the pencil trick? What's the equation of a vertical line? No. If it's vertical, which axis is it cutting through? X, right? When you're doing domain, we're using a vertical line. Which variable are you looking at? The x, right? Domain's the x. So if you use your pencil, you start to realize this is x equals a number. This is the y-axis, right, for your range. So we're going to do y equals a number for horizontal. So by doing the pencil, you start to realize x equals is vertical, y equals is horizontal for numbers. It's a very cool trick to use. What's the first, if I go vertical, x value it starts at? -2. It's still touching until what y value? Sorry, to what x value? 1. Your x is between -2 and 1. Least to greatest, left to right. So if I do my y for the range, I start at the bottom. What's the first y number? 0. So here's what's interesting. Where does it stop touching the graph?
4.
You say 4? Why not 1? Because if I do a horizontal line here, it's touching the graph, right? When I go above it and I start dragging, yeah, it's not touching here anymore, but is it touching the graph? Any part of the graph, right? So it doesn't matter that, oh, it stopped over here on the right side. Doesn't matter as long as it's touching any part of the graph. Is that a function, yes or no? Yes.
But it touched twice on the bottom.
Ooh, good part. Very good question. But it touched twice on the bottom, right there. Is it a function? Yes. Yes.
Why?
Why? Somebody want to answer a question? Why is it? It intersects because it intersects twice. If it intersects more than once, it's not a function. That's what the rule says. Why?
That's a horizontal line touching the horizontal line.
Because the rule goes with the vertical line test. This is a horizontal line. Horizontal line can intersect many times. It doesn't matter how many times. It'll still be a function. It's the vertical line test because if I were to pick this point, let's say 1/2, 1/2, right? It's a really good question. 1/2, 1/2, we'll say. If I were to pick this point, let's just make it easy. -1/2, 1/2. Are my x's repeating? That determines a function, right? The y's can repeat all they want. It's the x's can't repeat. Good? It's a very good question. All right, let's do this one. This is a fun one. What's your domain? Y equals x squared minus 1, where -2 is less than or equal to x, less than or equal to 2. Now, you probably don't understand what this even means. This means you graph this function only when x equals these numbers. So what's the first number your x can be? What? -2. Because it can be equal to 2, can it? The first x number I have is -2. Plug it in. What's -2 squared? 4. What's 4 minus 1? 3. The next nice number it can be now is -1. -1 squared is 1. 1 minus 1 is 0. I then can plug in 0. 0 squared minus 1 is -1. I can plug in 1 too, can't I? If I plug in 1, 1 squared minus 1 is 0, isn't it? If I plug in 2, 2 squared minus 1 is 3. Can I plug in 3? Am I allowed to plug in 3? Because this says use this equation only with these x's, correct? What's your domain? What'd you say? This is our domain. Don't worry. We start to do something called piecewise functions, and you realize they can give us the domain. My range, what's the smallest y I have in my list? -1 is less than or equal to y, less than or equal to 3. This is a graph. If I plug it in my calculator, it would look like this. It's a quadratic. We are not gotten to quadratics yet, but I can still give you the graph and you can plot it. All right, so here we go. Identify the domain and range. First, let's figure out if it's a function. Is this a function, yes or no? No. It fails the vertical line test. What's my domain? So use D for domain. Pencil goes what direction for domain? Vertical. What's the first, if I start on the left, what's the first x value it hits? 0. So 0 less than or equal to x less than or equal to, now I keep going. It's still touching until what x value? 4. Range. Now you turn your pencil horizontal. Least to greatest, bottom to top. What's the first y value it hits? 1. 1 less than or equal to y less than or equal to, what's the top y value it hits? 7. There's your domain and range. Evaluate the graph when x equals 2. What that means is if I plug in 2, what y value do I get? So if I go to my x-axis, I find the number 2. If I plug that in, what is the y value for those points? So what's the y value at this point? 1. I mean, if I plug in 2, this is the point 2, 1, isn't it? Is that the only answer? If I want to evaluate when x equals 2, I get y equals 1, don't I? Do I get another number? There's also a point at 2, 7. Or 7. How many y's attached to that x? 2. That means not a function, right? I plug in 2, I get 2 different numbers. Evaluate the graph when x equals 4. What that means is find 4 on the x-axis. What's the y value of that coordinate? So then y equals 4. Is it a function? We said no. It fails the vertical line test. Every year, it's been struggling with this. Is domain and range is such an easy concept. We get it in Philly. Students are like this, and they say they get it in class, and it makes sense. And then when you do the homework, there's tons of questions. Do you understand the vertical pencil, the horizontal pencil, starting point, ending point? Okay, it's really crucial to do an interval notation. Interval notation is a lot easier. So, domain and range. Vertical pencil. What is the first x value it hits from left to right? -5. Less than or equal to x. And as I don't just lift up the pencil. Drag the pencil and you see it's still touching the graph, still touching the graph, still touching the graph until what x value? 7. Then I do my range. Now the pencil goes what way? Range is what? Vertical, horizontal. Maybe saying horizontal? Go horizontal, least to greatest. Bottom to top. What's the first y value it hits? -1. And you said 4? Yep. As long as it's touching the graph, you keep dragging up. So even though these 2 points, it'll stop hitting this right side as I go up, it's still touching over here. Now, different notation, but it means the same thing. This and these 2 are the same. This means f of -1. Find f of -1, which means find the value of the function. So find the value of the function of x equals -1. So that means I go to x equals -1 right here. What is the y value at that point? 2. So even though I don't know what the equation of this graph is, I can still find the y value if I plug it in by looking at the point. F of 6. So that means when x equals 6, what's y? What is it? It's 0. Here's x equals 6. This is the point 6, 0. The y is 0. Is it a function, yes or no? Yes. The vertical line test passes. There's no repeating x's. What's weird about number 9? Ooh, domain and range. This is fun. Domain. X values, correct? This is where your pencil is really important because we're going to be going into this stuff in this chapter. You're going to find domain and range. Vertical pencil, left to right. What's the first number it hits? -4. That wasn't bad. And notice it's what type of dot? Well, the first -4 is solid, isn't it? X. As it goes to the right, notice what happens here. It opens, right? And what X value? Was it 2? So less than 2. Now here's what's interesting. Here we go, correct? What happens if I go to the right of 2 just a little bit? What happens if I go to the right of 2 just a little bit? Let's say 3. Well, not 3. Let's go 2.5. Right here, 2.5. What's it touching? The vertical line, your pencil. What is it touching 2.5? No, not 2.5. Nothing. It is no part of the graph, correct? Now to do that, that's an OR. We use OR. We've seen the ands. What's an OR? An OR is when your pencil, as you're dragging left to right, it stops touching part of the graph. If you look at it, you have 2 segments away from each other, right? So your X values exist here, or they exist here, don't they? Question. I said 2. Oh, no, it's less than 2. Because this is the start. If I say less than 1, you're saying this is the stopping point. 1.5 works, doesn't it? It's a good question. 1.8 works. Just don't put the or equal to at 2. And then 1.9997 works, 1.9995 works, and so on. What the other one? As you go left to right, what number does it start up at? 3. That's a closed circle, isn't it? Still touches until what X value? 6. That's an open circle. So there we go. This is the hardest. Range. This is fun. Oh, we do this in pre-calculus. By the way, you get really good pre-calculus. Once you learn interval notation, it's so much easier. This is annoying to me. Because interval notation is just where does it start, where does it stop, and you just learn how to write it. As I go least to greatest, what's the first Y value it touches? What's interesting about -3? There's a closed on the right, well for you guys, sorry, on the left, and there's a open on the right. Do I do or equal to? I have -3, and my Y, do I put the less than or equal to, or do I just put less than? What? Y. You're right. Because though it's not included here, is it included here? Yes. So an equal to, an closed circle trumps an open circle, doesn't it? Okay, as you go up horizontally, is it still touching the graph? What happens when I go past this segment? Is it still touching the graph? So we can just throw away that segment on the right, can't we? I mean, I don't care. Well, stop touching this graph. But it's still touching the entire picture, isn't it? Until what Y value? That's the 6. And that's an open circle. So even though there's 2 segments, you don't have one inequality for your range because it's only touching. All right. F of -2. So when X equals -2, what's your Y? So here's -2. What's your Y? 0. When X equals 3, what's your Y? Looks like -1. Is this a function? When you did the vertical line test, by the way, when you're doing domain, you're actually also testing if it's a function, aren't you? Did it ever intersect more than once on the graph? Nope. Yes, it passes the vertical line test. That's domain and range. Good? Then let me ask you this question. What did this mean? F of negative 2. What did that mean? X equals what? And you plugged it into the function, but you didn't have an equation to plug it into. You plugged it into the graph, right? That's what this means. Function notation does not mean f times x. This does not mean f times x. This means f of x. It's on the front page of your notes explaining this to you on it. What this notation means, it does not mean take f multiplied by negative 4. This means when x equals negative 4, what's the value of the function? So what I do is I plug in negative 4. So f of negative 4 means instead of x squared, guess what number I put in for x? Negative 4. Instead of minus 4x, what number do I put in? Minus 4 times negative 4 plus 8. And I just worry about the right side. What's negative 4 squared? 16. Negative 4 is 16. And then plus 8, I believe I get 40, don't I? If you were to plug this in your calculator, and you were to go hit graph, and you scroll down to your table, guess what the y value is at the point of negative 4 for your x? It'd be all the way up on 40 on your calculator. You're still finding a point. But here's a weird one. F of x plus 2. This is the hardest you can get. Star this. This is the foundation to plugging everything in. This means instead of x squared, what am I going to do? X plus 2 squared. Instead of x, I'm putting x plus 2 in. Whatever's in this parentheses, whatever's in the parentheses replaces the variable. I don't care if it's an x plus 2. I don't care if it's an a plus 2. I don't care if it's a 7. I don't care if it's 42. I don't care if it's negative 28 ABC. Whatever's in the parentheses replaces your variable. Does that make sense? The object goes in. Minus 4x. But instead of 4x, what am I going to put in? X plus 2 and plus 8. And I say star this because of this right here. What does it mean to square something? X plus 2, x plus 2. You would do what next? Yes, use the word distribute. I don't like the word FOIL. X squared plus 2x plus 2x plus 4. When I combine like terms, I get x squared plus 4x plus 4. And what happens is there's this idea. People think there's a shortcut. Could I have just, oh look, I have a squared. Could I have just squared the first term? What's x squared? Could have squared the first term, couldn't I? Could I just square the last term? What's 2 squared? 4. Could I have just squared the last term? I'm missing this middle term, aren't I? When you try and do the shortcut, you cannot take an exponent across a plus or minus sign. That's order of operations. Can you do exponents at the same time you do addition? No. So exponents can never cross a plus or minus sign. So you cannot square that way. You have to write it twice. And I get minus 4x minus 8 plus 8. If I combine like terms, hey, negative 8 and 8 cancel, don't they? I have a 4x and a negative 4x. I just get x squared plus 4 for my answer. That's cool. Squaring a binomial is the thing that gives math teachers just like nightmares. Students want to take the square, just square the first term, square the second term. They miss this term. And it annoys us. And the reason why is we learned there's a pattern for squaring binomials. Pascal, mathematician, created Pascal's triangle for squaring, cubing, raising things to the fourth power, and so on. It will help you to learn it. We kind of learn it in pre-calculus as well. Interval notation is going to be on Monday. So, get the homework out and I'll tell you which ones to work on.